Hello, I'm John Nicolopoulos, and this is my fully 3D printed drone project. I will first demonstrate my drone that is operational, and then I will discuss how I built it and show you the steps I took. It is capable of hovering, it's flying, it's happy. Now, the kit I used the suggested DIY drone building kit from Amazon, suggested as on the project page. I only used all the electrical components, which includes the motherboard, the motors, the battery, and the propellers, since those are a little more difficult to manufacture. Everything else is 3D printed, as the chassis itself, the cage to hold the battery in place, and the cage to protect the board on top and keep it from flying off. Now, what I had done to design this is I tried to keep it as 3D printing friendly as possible by having clean, flat surfaces as base builds. So when I built my chassis, my main body for the drone, I had the orientation to fully be flat and keep as minimal supports as possible. I didn't want to do a lot of breakaways since this is a smaller print, and small print breakaways might end up damaging my main parts. As I did the same for my board cage on top, I laid it flat on the ground so there's no supports necessary during 3D printing. The only supports needed were in the circles itself for my through holes to have my screws through, but that was no problem. I only had one issue with those, since having supports in a 3mm hole is a little difficult to take out, but I fixed it with just a drill and just a power drill. My holes for the 3D printed body came out perfectly nice. Everything was okay, same as the cage underneath. When I had gotten the parts, I had the brim all around. I cut that away with a razor knife. Didn't use any heating elements because it was a nice enough clean, so that wasn't required. Assembling this with a number 2 screw to sandwich the top board cage, I called it, the body, and the battery cage all together to sandwich. It actually bites into the battery cage itself, so the through holes are on the cage on top and the body on bottom. I designed this so that the board itself has slots to be slit into the body so that this board cannot move freely on its own. I didn't have to glue or anything. I could just leave it as is. Just slide it in, call it a day. Make production a lot easier. So assembling this only required 2 screws and a little bit of cutaway for the brim. The only issues I did have, though, were from the assembly of my motors. I had designed them so that they are just you could just push them in, and it would have enough material and tightness that it would squeeze against these motors so they wouldn't be flying out, which it worked out well. But when I first started assembling them, they were a bit tight, and they did cause some hairline cracks on my print, as you can see right there. Maybe you cannot see, but it's there. So I took some needle files and filed away at my little imprints inside and helped relieve that pressure. So no more cracking would form. And my original intent was to have these motors sit flat as intended right now, but underneath, as I did a little slot so these cables could run through as I pushed the motor through, since the cables are on the bottom of the motor, I did not have them deep enough in my original design and print. But I did a quick fix by taking a soldering iron and just melting away at the plastic a little bit, and then filing away the excess plastic that left a burrow on top that would collide with the motor. And that helped sit all my motors in place perfectly. And on top of that, I also wanted to design this so that when it lands, it wouldn't want to topple over. It's steady level ground. So I extended all these motor stands all the way, so they are actually the feet of the drone itself too. Other than that, my only improvement would be to redesign the print for the wires to be more friendly, motor friendly. Also, to relieve some pressure on all these motor mounts by taking away some material in the files themselves. I also, as it will be in my report, I have set up my G-code so that all three of these components that are printed are all in the same project, so I only have to do one whole print for this entire build, and of course the kit that comes along with this that is bought separately, so that I don't waste any operation time by, sending in one part to print, taking that out, redoing the process to upload a new file for, like, let's say the top part or the bottom part. It just makes operation time cut down significantly. And that is it for my own personal design process. The designing was not that hard. I used some inspiration from some little tiny drones that I already looked into so far. I wanted to keep this lightweight, but I didn't really care too much about how wide it is, since it is a tiny project. I did want to expand my wingspan of these motors as much as possible to give them as much stabilization. I assume, I could be wrong, but so far it flies very well. So I did want to expand that. Instead of, like, let's say 60 millimeters of perimeter, it's more of it's 90 millimeters of perimeter now, so they have a larger, I guess you'd say, wingspan. Yeah, this came out very nicely. I'm very happy. The designing process in Creo was time consuming. Even with my previous experiences with Creo, it's always very time consuming. Fun. I put on some music. It's not bad, but my best experience with this project, I would say, would be the actual printing itself, incorporating my drawings into printing, since that's the first time I actually incorporated my drawings into 3D printing. That was very interesting. And I got to see my parts in person and line them up all together, and lining them up together for the first time after a first prototype is a very good feeling for me, when everything just fits in and I got my measurements right. That is a really good feeling for me. I would say I learned a fair deal about designing miniature devices, at least. Taught me how delicate and how precise you'd have to be to get, things like a motor in. How do you want that to sit in? Is it going to damage any other parts? What type of material may be better to use? I used PLA for this. I wanted it to be sturdy. I didn't care about flexibility because it's just a little aviation drone. But yeah, I had a lot of fun building this project. Minor road bumps I encountered, but a success all in all. And this was my first and only print with only minor adjustments that needed to be made. That can, only need an update on the design part itself. Everything came out perfect. I'm very happy. And yeah, that is my part. That is my project. Thank you very much.